Lions Rock Productions.
This is Popping the Bubble with hosts Sandra Ponce de Leon and Pete A. Turner.
Hi, I'm Joe Luttwak, CEO of Lingrove. We make wood without trees, and we're listening to Popping the Bubble.
Wow, wood without trees. I'm so intrigued. Hey, Joe. Thanks for joining us. We are here at the Vault, located in the heart of San Francisco. It's a collaborative workspace and innovation hub. The Vault celebrates entrepreneurs and innovators from around the world and provides them with the right tools and support to grow better and faster. Thank you so much, the Vault, for having us. We love being here, and it's so great to meet you, Joe, and find out about Lingrove. So why don't we just jump right into it? What does Lingrove do?
We started years ago with idea that we could make a better than wood replacer. And so it brings the question, so why, right? So many people don't know this, but we're surrounded here in Northern California with some of the biggest and tallest trees on the planet.
That's true.
And what's not known is that the wood in these trees is actually the best performance material nature.
The wood. So when you say trees, there's redwood. We're surrounded by redwood trees. What kind of trees?
So the old growth trees they have a stiffness to weight ratio that's basically equivalent to steel, right? And so actually the building we're in here, you can't see it on the podcast, but this is all old growth wood, which is great.
Oh, the beams.
The beams, in case of an earthquake, that would be the ideal material. It's literally stronger, stiffer, and more resistant than anything you can buy at your local Home Depot. So, so my kid asked me, how is it these trees grow 30 stories tall, right?
Right.
And have a very narrow trunk diameter. And the answer is they're made out of a better quality wood. A wood that we ideally would use to make our interiors and our exteriors because it's a better quality material than what you can get today at your hardware store. And so the whole point of Lingrove is to emulate this wood. And why? Because 87% of these trees are gone forever.
Right.
Right? It's a non-renewable resource.
Right.
So that's the main
and it takes
thrust.
hundreds and hundreds of years for them to even get to that height.
Exactly.
And diameter.
Yeah, and so we think that biology is the solution to a lot of the world's big problems. That deforestation is one of those big problems, and that if we can make something for people that's actually better than old growth wood, then folks will have no reason to buy, exotic old growth woods. The market will die for that product, and we'll have something that's replacing that.
Yeah. So I mean, how do you do that? I mean, you're part of the Indie Bio Accelerator program, and you had we just went to demo day yesterday, and we got to see some of your products. So how do you make a material that is like an old growth redwood tree and has the same properties?
So let me step back for a second.
Okay.
So old growth today, they don't know how big the market is, but they say that it's a estimated $50 billion black market.
Black market.
Yes.
Oh.
Illegally poached wood, right?
Oh.
And so it's a massive, massive industry. The fact that they're almost all gone is really sad for folks that like to hug trees like myself, but it also represents roughly 20% of CO2 emissions. So deforestation is one of our big problems, right? It's like construction, food, deforestation, energy production. If we can address those four major issues, we can actually turn the tide on global warming.
Yes.
And so that's a big problem that we're trying to solve. Indie Bio is oriented to solving large problems all across
humanity's
the spectrum.
Largest problems.
Yeah,
yes.
So some of that is therapeutics.
Yeah.
Some of that is biomaterials, and we're fitting into the latter category. So it's a broad spectrum, very interesting program. And so they have a lab, which is great, and that helps accelerate some companies. For us, we actually have our own facility in San Francisco doing manufacturing. So
okay.
For us, Indie Bio was saying, hey, let's focus on the important stuff, get to scale as fast as possible, connect with your big customers as fast as possible, and don't languish in the land of email hell where nothing's getting done, but focus on the big picture.
Right.
And so in like 5 scant months, we went from being doing this project and that project to focusing on the big markets that will actually move the needle as far as wood consumption.
Wow.
So Indie Bio, they pushed us to create a specific product for the big verticals that we're chasing after. And if we're talking about replacing wood on a massive scale, today we're in sports equipment. I started a guitar
Like
company.
bats? Like baseball bats?
We have arrows, fly rods,
Bicycle frames.
Right.
more on the product kind of pilot level. And so in those fields, we're replacing actually carbon fiber because our material's as strong as kind of high-end composites like that.
Yeah.
And so that's cool. It showed proof of concept, right? Again, when I say better than wood, we're talking about strength. We're talking about aesthetics.
And light,
durability.
it's much more lightweight as well,
Yeah.
as we can attest to because we lifted some of your products.
Yeah, so proof. You're my like living witness here. It's about 4 times the stiffness to weight of steel,
Wow.
and
yeah.
6 times compared to wood, and then more than 10 times the tensile strength. So that's a pulling apart kind of strength. So again, when you think about solving some of the world's big problems, part of that for me is very basic. It's lightweighting, right? Lightweighting transportation, lightweighting our buildings, lightweighting all of the transportation of goods.
It's an exponential return because
Yep.
it's thermodynamics, right? Like you've got a hunk of weight, you've got to move.
Yep.
It takes energy. That energy is spent. Boom. That's right.
Yep.
That's a whole lot of not talking, but yeah, I get what you're saying.
Yeah, and it's complicated stuff, but that is a big part
So,
of the picture.
like lightweighting, just by making something lighter weight, you're using less energy
Correct.
to create it. Okay.
Well,
That
not
makes-
necessarily to create it, but
Okay.
you're using less energy in the
move it.
final object. So if it's a car, it's obvious, right? Because
Right.
it's less fuel for your lighter car. But if it's a house, it's a little bit less obvious. It's just a matter of transportation of those materials, right? So you're extracting it. We'll talk about that. But you have this thing, and you have to move it on a truck in the U.S. typically, right?
Yeah, like if you're going to do new floors,
Yep.
you're going to move 5,000 pounds of some kind of substance, tile, linoleum, whatever it's going to be. If yours is 3,000 pounds of stuff, that's 2,000 less pounds you have to move.
Yep.
And also, you can move more into more places more efficiently as well.
Yeah.
You'd also get an efficiency build. Okay?
Yeah, you can fill up a
Yeah,
truck
that
more.
makes sense.
So that's one thing that one can do with our class of materials. We call it composites, right?
Okay.
That's the world of materials that we're in. We're in the biocomposite subset of that.
Okay.
And so what we're adding on top of the lightweighting thing, which is an important thing that composites do, fiberglass, carbon fiber do for us today, is that we're talking about growing, fast growing plants to replace materials that we have to spend a lot of energy to extract, metals,
Wow.
or cut down old
Right.
growth woods, which cause deforestation, of course, obvious, and therefore CO2 emissions,
Yes.
on a massive scale. And so, our verticals, let's say interiors, right? We're talking metals and woods. Those are like high energy embodiment or a lot of CO2. Exteriors eventually is another market we're looking at. So actually buildings made out of fast growing plants. And then you're talking concrete.
Do you have a name for your composite? Have you come up with a name for it?
We have. Thanks for bringing that up.
Oh, okay.
Yes, ECOA. Ask for it in your local store soon
Nice.
enough.
ECOA.
ECOA. So yeah, it's
Okay.
actually a conjunction EKOA.
Okay.
And so, of course, ecological on one side, and then koa, which is kind of inspirational wood for us. That's an endangered wood from Hawaii that was typically used for high-end furniture and ukuleles. And so, also it's part of the acacia tree subset. I'm kind of a tree nerd, as you could probably guess here. So ECOA it represents kind of beauty and ecological quality, and we believe that branding a material that has this, high performance, beauty, and by the way, it's CO2 negative, is kind of the way to do it, right? We want people to desire an object made out of ECOA, and then be happy that they have it because they know they're doing something to help, with
Yeah.
reverse climate change.
Yeah. Oh, I've seen the chair, and I desire it.
Good. That's quite great.
And I think that Pete has seen the guitar, and he
Oh my
desires that
God,
guitar
yeah.
as well.
Well, I told you that I wanted to get a composite guitar a while back,
Yep.
so I'm just gonna have to get yours instead of the other one now.
There you
that's,
go.
That's
Excited.
amazing. So you talked a little bit about the plant, and you have a name for the material. But so how do you get from plant to material?
Yes, I actually answer your question now. I've delayed how long? So
Unless it's a secret, unless it's a trade
no,
secret
it's
you don't
not.
want to discuss.
We do have a lot of trade secrets, but that's not one of them. So we're using flax.
Flax.
Flax is and flax is actually the oldest textile grown by humans.
This is true.
Tens of thousands of years.
I just thought it was good for me, and I put it in my shakes.
It allegedly, I can't attest to that. I'm not a nutritionist.
We can
I know,
tell.
I need to have a. Whoa, what? What does that mean, Pete? You shouldn't be talking. I actually
I was
shouldn't
gonna say,
bike here.
says the fat guy in the
Yeah,
room.
come on, dude. Yeah, I bike every day. Thank you very much. You're from LA, right?
I'm from here, but I live in LA. Yeah, and I'm
See,
not
we need
pretty
you
enough
back up
to.
here.
Yeah,
Come
right.
on. All that driving, dude. So where was I?
You're being
yeah.
called fat. That's what you're.
Oh, that's great.
And you're not. You're not at all.
You guys,
fat.
you have editing software, right? You can edit stuff.
We're gonna
out.
edit this out. Yes, we should edit
Pete,
this
there's
out.
a lot of value add coming from your part of the radio show here. As long as you don't say anything to Sandra, because she's
better
looking
not.
great
Sandra's
today.
lovely.
Yeah,
She's always
exactly.
He knows better.
Yeah,
I
It's okay.
definitely know better.
You have no interest in this guy. I'm good with that. Where were we? Oh yeah, flax. Yeah, you should eat a lot of omega-3s, Pete.
You know what I
covered
need
with
to.
flax
I
seeds.
should do.
Yeah. So that's how a lot of people know flax today.
Yes.
They also know linen, and linen is an often used word to describe, just our fabrics to cover the table in linens, but actually it comes historically from the flax plant.
Oh.
So you could buy linen shirts, and they're made from flax, right? You could buy the flax seeds, comes
all
from the same
linen
plant.
is made from flax?
It is become a bastardized term,
Oh.
but that's
Yeah.
historically where it's from.
Wow. Okay.
And so we still have it around. Cotton, unfortunately, has become more popular, which is a problem because cotton uses a lot of water. And it just, there's a whole history there we don't have to go into. But suffice it to say, one takeaway from this podcast is if you want to be more eco-conscious, buy linen, don't buy cotton whenever you can.
And ECOA.
And ECOA,
products.
right? I know. So I mean, for me, I'm partially evangelist for choosing the right materials in our lives, regardless of the application. We picked flax because it is the stiffest natural fiber. So it's the highest performance of all of
And
the
it's
natural
hardy.
fibers.
It can grow anywhere, right? It's really
hardy. Typically, it's grown in northern climates where it's wet. And so that's Canada, actually, for the seeds, and they throw away the stalk. We get the fiber from the stalk,
Okay.
nice.
and it's from the middle of the stalk. So we remove the stalk, we get the fiber, and we make a continuous long fiber with that stalk. And that's the key of composites is long fibers, right? That's what
Yeah.
makes it like wood. Wood is really strong as long fibers. So we have a better than wood fiber.
Huh.
And another part of our process is a proprietary resin, so plastic, essentially, that's from biosources, recyclable. Better than lignin, which is the wood resin, typical wood resin, so it's higher performance. That we combine those together, and we have our better than wood replacer. And that's a composite process that's proprietary, but the ingredients in general are not.
Yeah.
And so it's the how we do it, how we make it waterproof, how we make it moldable.
Let me see if I got
look like
it's
wood.
lighter, stronger, faster growing.
Better for the environment.
Better for the environment. You're using something that wasn't necessarily being used before with the shaft, meaning like you've reduced, reused, Reese Witherspoon, all that stuff. And there's also
and more beautiful.
And more beautiful. It is. It is beautiful.
Yes.
What are we missing? That's a lot of stuff already.
Well, yeah. So on the eco side, I mean that is a lot of stuff already. CO2 negative.
Oh yeah, that's right. Yeah.
Right.
Yeah.
Doesn't require irrigation. Doesn't
Amazing.
require water, and that's part of where they grow it.
Yeah.
And so, it grows in 100 days versus 300 years. I don't know if we said that before, but an old growth wood will take 300 plus years. That's why they're non-renewable.
Yeah.
Wow.
But this takes 100 days. So it's a crop that you can grow and then grow wheat in the same field, for instance. So you're not necessarily even replacing, food stock.
Right.
So today we're using the highest performance stuff. It comes from Europe. In the future, we will vertically integrate and source the waste or the thrown away stocks from Canada. They're growing 1 million tons a year of the stocks, which they're not using for textile purposes today. So we're like in touch with folks in Saskatchewan, which I know how to pronounce now, and I'm really proud of that.
What's the wrong way that we all say?
Saskatchewan.
I don't want to curse. I'm sure I'm going to curse if I say it. Yeah, Bigfoot.
Bigfoot.
Yeah.
Squatch.
So, and Canada across all of that, like Manitoba, that area, it's like a big opportunity in North America for us to grow these fibers. So flax is what we picked because it's the highest performance.
Yeah.
It's not the only plant fiber that can be scaled up and replace structural materials. It's the one we picked because today we can get it and make it look like wood. And that's where a lot of people fall short, right? Is they make this awesome thing and it looks like brown mass, and turns out no one wants to buy like a dirty brown plastic looking thing, right?
Yeah.
So that's one area. I'm a product designer by trade. So I look at the end product and I say, how do we make something that people actually want?
Right.
And then if we can infuse it with, high performance and ecological values, by the way, kind of, tertiary benefits like that, great. But first and foremost, they have to want it. And so we're using these long fibers. We're emulating wood. It's an authentic finish. It's not trying to copy wood. You see the grain. The grain is the structure. The outside grain, that shell, is the structure. And so yeah, that's our angle. Is that we want to create that desire in people for that object first and foremost, so that we win in the marketplace with these materials and people actually will adopt them over the other stuff.
Yeah.
So that's
how goes the fundraising? I mean, like, you've already got me sold. If I had money, I'd give it to you. I mean, what's is it?
Yeah. Do you have products in market already? What's the status? Of
Yeah.
that?
So we have pilots out there, as I said, in sports that show that this thing is durable, it's strong, as I said,
so
right?
Cool.
And it looks nice. Our biggest score to date is working with some of the big furniture companies in the U.S. And transportation brands. So I was in the call today with a tier 1 auto company, boat manufacturers. So those are the big verticals we're looking at. And so we have a letter of intent, which means that they're interested in buying material, like a large order of material from
that's great,
the biggest commercial furniture company on the planet. And so, one side table from them, and that pays for 6 months of operations. So we've been working there for a while.
Is this one of the affordable biggest furniture companies in the world, or?
I can neither confirm. No. Yeah. Someday we'll get to those guys.
Yeah, it's more in the high. So the product
it's
price
mid-range.
Point is a little bit, okay.
Yeah, mid-range. This is more like office furniture kind of stuff where people are willing to pay a small premium, because we're right now we're sitting at carbon fiber replacing prices, and we're raising money to scale to the point where we can create our continuous machine and process materials for the interiors market, which would be about $2 a square foot, a bit lower than where we're sitting today. And then to go like mass market will be a couple years, and that would be more like $1.50. And then we're talking, your local big box furniture store.
Yeah.
Because folks like let's call them by name, like IKEA.
Right.
Bless their hearts, they're actually committed to replacing wood, using what's called FSC wood, which is Forest Stewardship Council, which means they're following the wood from the forest to the final piece of furniture in their factory. And so now they're claimed to be at 75% FSC wood. FSC is not the perfect solution, but it's the best we have placed today. From my understanding, they can't source enough wood. IKEA uses 1% of the world's wood.
Wow.
Yeah.
And so they're simply maxing out on these eco forests. FSC forest, they're going to be non-monocrop culture, right? That's one thing. We don't want monoculture agriculture. It doesn't work. And not poached wood, of course. And so they're getting to the physical limits of what's available. FSC is getting maxed out because just IKEA alone.
Wow.
That would be a great customer when we're ready for them.
Yeah.
And I think that's the other big part of the story is that, a lot of companies are doing biomaterials now, and it's, it's an exciting space. We need solutions, but we need them today. And so we have a solution that is ready to scale today because we're using textile processes to scale. We're not in a lab, in a a fermenter or a reactor. We're actually using these continuous processes that are based on the original Industrial Revolution technology, right?
Yeah.
Textiles created the Industrial Revolution in the mid 19th century, right? That's where the Industrial
Good old
Revolution.
Eli Whitney.
There you go. So yes, yeah, and Jethro Tull
Oh yeah.
bringing it back to Break It Down show. Yeah.
Exactly.
So that we're refining and automating some of these processes that have been around for a while and are continuous. And so our machine, our pilot machine that we're building today, and we're raising money to kind of augment and to create our first, let's say, production run by the end of this year in about 6 months. It can produce about Portland to Los Angeles worth of material annually, right?
Wow.
1,000 miles. And
Holy shit.
So we can do this quickly. We can get up and running quickly. And we can produce a lot of material, even on a pilot machine, even in a single shift.
That's amazing.
And so we see 10 of these running under solar power somewhere in the desert in, a couple of years. And at that point, we're replacing, square miles worth of virgin forest.
Yeah.
That's what we're marching towards.
Wow, that's incredible. What was the aha moment? When did the light go off that this was something that was possible and something that you wanted to pursue?
I actually came at this from a really bizarre background. So I started at Ferrari in Italy.
Nice job.
Yeah, it was really cool. And the food doesn't suck over there
No.
either.
No, not suck.
They used to have Lambrusco, which is that bubbly wine, just on tap at the cafeteria. So it was like midday.
Wow.
We're coming in, and I was, those guys were complaining about the food. I'm like, this is literally the best Italian restaurant. And it's like part of the pay at Ferrari. Yeah, I love to tell everyone that.
That's
and then, and then all
hilarious.
these guys are like doing manufacturing, drinking, a half liter of wine, at lunch. But anyway, it works out for them. Probably not public information that Ferrari wants me to go spreading around. So I'm a composites nerd, right? So carbon fiber, molding carbon fiber, high performance parts. I learned a lot there, handling their, I was over there at their F1 department, like cataloging parts. I was, a peon, of course, but this was 20 years ago. And I just got to handle some of these suspension parts. I was like, what? This thing holds up a 2,000-pound car. It can handle 200 miles an hour and high G forces around the track. And so I bottled that. I went to school and studied design. And when I got out of design, I took that kind of F1 car concept and applied it to a guitar, of all things. Made a unibody guitar, one piece, all hollow, and used composites, used carbon fiber to do that. And we made a bunch of these carbon fiber travel guitars and launched this Blackbird guitar company. And doing that taught me a lot about manufacturing composites. I became a composites manufacturer. I made parts for Yamaha and for all these different companies. And it also taught me a lot about what people want. And at the end of the day, a lot of folks in the music industry said, hey, can you give us, something like awesome, durable, and you can take anywhere, just like this travel guitar, but we don't want it to look black like carbon fiber. We want it to sound like wood, and preferably old growth wood, which is what everyone wants in their grandma's guitar. In the guitar industry, everyone wants like 100-year-old guitar.
Right.
It's really bizarre.
Huh.
And that actually even extends to electric guitars. We made acoustic guitars. Blackbird's still manufacturing today. We made, we started thinking about how do we replace carbon fiber. So it wasn't like the aha moment was me searching around on the internet nearly 10 years ago. Bless the internet. And I found this notion that you could have a kind of composite material, right? Fiber and resin together, but that the fiber didn't need to come from petroleum sources. It could come from plants. And at the time, no one had really developed it. So we pursued it with a couple of folks out there at the time, and we couldn't really get the product to be the spec that we wanted. Guitars have to be super stiff and super light. It's not unlike a plane, actually. So people don't realize it's a structural object, super high stiffness to weight ratio, and that's why we can only use old growth rainforest wood for guitars. Carbon fiber works because it's incredibly high stiffness to weight. And after that moment of kind of finding out that you could have a natural version of carbon fiber,
Right.
then it became, my job and my company's job to figure out how to connect the pieces. And so we experimented, and that became a long R&D process. So it took us about 5 years off and on to go from that to selecting linen fiber as our fiber, to formulating a resin to work with that linen fiber, and then to launching initially a ukulele that, ECOAs, Koa ukuleles were replacing with our ECOA material. And so, aha moment led to 5 years of
Right.
hell, and
Nice.
then a lot of learning after that. And so Blackbird became our R&D kind of test bed. And I'm happy to say that company's shifted entirely from carbon fiber now to the ECOA materials. Serves as a great example of taking a product to market alongside super high-end, premium wood instruments at the same stores and selling. We can't make enough of them.
Wow.
Yeah,
How much does one of these go for? Sorry.
they're gorgeous too. By the way, I'm on the website blackbirdguitar.com. You guys should all go there and check it out because they're
Yeah.
incredible.
They've been really well received, mainly for the performance.
Right.
And that's my thesis about all this: is you give someone something better, and then the materials matter.
Yeah.
Right.
Yeah. I love that. Is this a form of carbon sequestration?
Hey everybody, Pete A. Turner, co-host of Popping the Bubble. This episode is sponsored by us over here at Lions Rock Productions. What do we do? Content management strategy. We'll help you create podcasts, develop strategies, consult on what you've got. If you want to take a look at content, we would love to have an opportunity to do that for you. Now let's get back to Popping the Bubble.
It is, yeah. So you grow the plant,
Yep.
and the plant is CO2 negative because it is sequestered carbon.
Right. Yeah, I'm fascinated by this because I'm working with a client right now that's building a carbon removal marketplace on the blockchain. So they want to create a market for producers like you of carbon negative materials to be able to exchange in a marketplace for that and actually to get a value out of it, beyond the products that you're making even.
Yeah, I think quantifying that for companies and for the world is definitely a missing piece. I can tell people till, I'm blue in the face about it, but it should have a value beyond even just it feels good.
Right.
Yeah.
And then, kind of growing that across fields, literally and figuratively, would be great. So if someone's doing that, I'd love to hear more about it.
Yeah. I'll connect you after this.
And Lingrove is lingrove.com. You can
Lingrove,
find out
yeah.
about all of the solid linen ECOA-based products, whether it's flooring or anything, chairs.
Yeah, and so to clarify that, so today we are selling a branded material, right? We don't make parts. We sell the material to other folks that are hopefully better than we would ever be. We made a chair for the demo day yesterday, and we may go into limited production of that if Sandra
hope
can't,
so.
if she can't resist.
I desire it
She
so
cannot
badly.
resist.
Yeah, she's been desiring it so strongly. So I've generated at least in the chair, I've generated desire.
She's got FOMO like crazy.
Yeah. So we have these rolls of material, and that's what we sell to folks.
And the material, the raw material, it can be formed however you want. So
Yeah.
it's got that ability. And
Yeah, so-
you don't need the molds per se of the items, or that's something the manufacturer would give to you, or
you
you
wor-
just hand it to them and you're like normal production.
That's the idea.
processes.
Yeah.
Oh, okay.
Yeah. So they would mold it,
Yeah.
and there's connecting the dots for them, right? Depending on how much they know about composites. But typically they have, let's say, plastic molding capability, and we can more or less plug into that.
Right.
And so that's a really important part of the thing too, is they need it to be something they can mass produce. And so what we've developed at IndieBio is a version of our material that's actually mass producible. So what that means is it goes in the mold for a minute instead of for an hour. Right?
Wow.
Traditional composites take a while to mold, and
A
that's
minute?
why. Yeah.
Wow.
A minute, which is like a typical what they call thermoplastic, really fast processing. So, you look around at stuff, what we have on this table, we have, these parts here in your water bottle, those are thermoplastics. Most of when we say plastic,
Yeah.
well, a lot of it's a dirty word for good reason.
Yep.
But it can also be, fast molding and recyclable and plant-based and all of that. And so that's the materials that we're working on. Those plug into a manufacturer so that they can produce parts fast enough. And that's what they need to actually adopt a material, right? They won't do it if it takes an hour in the mold. They
Right.
told us that to our face. and that's why we
Wow.
made this material, right?
Yeah.
We're like, oh, we love this stuff, but
Right.
we're just not going to put it in a mold for an hour. It just won't work for our cost structure. So that's one thing we sell today is the rolls. And the other thing, which is a little more like, say consumer facing. I mean, we really want people to start recognizing the ECOA name, because to us, we're really taking seriously that these are going to be bio-based and CO2 negative materials. And so it's important that end users understand the name and that they desire the name. So another form that's going to be more accessible is actually panels. So there is one version of this in the future where we're going to say, okay, you go to your local Home Depot and you can buy a panel that weighs just as, and that could suit your purpose just as well, but you don't have to schlep around this heavyweight wood and resin-based plywood panel.
Right.
And we're going towards pretty similar pricing too.
Very cool.
Yeah.
I love it.
Yeah,
I
I
think
do
the
too.
material is beautiful, and it's actually, I think what's cool about it is, plus the name, it's very easy to distinguish. It's not like anything you've actually ever seen in terms of a wood fiber or really any other kind of material. So I love that. It's really, really cool.
Awesome.
Yeah, I can't wait to see it in market or actually have my chair in my house.
Yeah, I kind of get a little over the top here because I kind of see the entire world
Yeah.
blanketed
bet.
in like fast growing plant fiber,
Nice.
ECOA. And so
Well, like the core of that whiteboard could absolutely be plant-based, the backing for it.
This table.
it's
Yeah.
that thing. Yeah, the thing is, there's almost it's almost can cover anything. I mean, even all these electronics enclosures, right?
Yeah.
All these Apple products, your Surface over there, that's all aluminum.
Yeah.
So
Yeah.
metal replacement is an obvious fit.
Like this frame right here.
Awesome.
It's
that
structural
holds this-
parts.
yeah.
Whoa.
And so as we scale, we can go into these other
Right.
industries. So today we're looking at sort of furniture where people are willing to pay a premium for performance and for aesthetics.
Sure, yeah.
But we're also talking to computer, for laptop manufacturing. We're actually
Very
talking to those
cool.
folks.
I mean, I would consider that. Like, I don't need this thing to be metal. That's just what they sell it in. If they had like an option, I would buy that.
Yeah.
Yeah, I mean, it's if it's made out of composites, it's less likely to break.
Yeah.
So, may not be in the interest of the consumer electronics manufacturers, but it's most
Well, they
certainly
can put
in
the
our
breaking
interest.
stuff on the inside.
Yeah, Gorilla Glass will take care of that
Yeah.
part. So especially for kind of portable stuff, you're adding value because you're making something stronger.
Yeah.
And so I think everyone really wants that ultimately, which is probably one of the reasons why they chose aluminum, because that was a step change improvement over some of the crappy plastics that came before.
Yeah.
Yeah. So yes, look for a world
Yes.
of fast-grown ECOA materials.
ECOA everywhere.
I love it.
Yeah.
Oh wow! You just coined one.
Oh, nice.
Wow, this is why she does what?
See?
Marketing and PR.
Yeah.
But I'd like to think I inspired you a little bit.
completely.
There. ECOA everywhere.
Yes.
I just trademarked that.
Right.
Do it.
my brain.
TM.
With
done.
my brain. Well, at least you've got a timestamp. So when someone
Yeah.
else tries to say it, you're like, no.
Right.
All right.
I've got a brain.
Yeah. Lingrove.com is where you can find out about what you guys do. Do you guys do Twitter, or where do you guys push people normally?
Twitter, Facebook, LinkedIn. Yeah.
You guys are everywhere. And then we're also going to have you
Kind
on
of, yeah.
the Break It Down show as well.
Awesome.
We'll talk about the guitar side of things, because that's another whole nother thing, and that's fascinating. So for sure we want to have that. But just in general, man, I just want to say thank you for thinking about this and figuring this out, because our planet it's our planet, and we should take better care of it. And I appreciate you helping us figure out some ways to do it. It's one thing to make it impossibly hard and expensive and say you have to do this. People aren't going to do that.
Right.
But this people can do, because
Absolutely.
it makes a lot of sense.
Yep.
Yeah,
Well, thanks for having me, guys.
Yeah,
it was
it's
great.
such a pleasure, and we do love what you're doing at Lingrove. So thank you so much for joining us.
All right, great. Well, I'll keep you posted.
Thanks, Joe.
All right.